Good day, Mr. Randall Scott, Seawright, Society of Petroleum Engineers, distinguished lecturer, and you have more than 47 years of experience.
Yes.
Antoine Thomas, you have 15 years of experience. You are a geologist, you are a reservoir engineer. Mr. Marat Sağındıkov, he is the head of Center for Enhanced Oil Recovery.
As an engineer, 35% recovery seems rather low.
They have recovery factor about 20% with zero water cut. Can you imagine it? Doing polymer flood is an industry standard. So it's normal for them just to do it from day one.
I think the truth is that what we see in a laboratory is correct, what we see in the field is correct, what we do with our basic petroleum engineering principles is correct. All three of those are correct. The only thing that's wrong is our interpretations.
The manager who says EOR is expensive agrees to lose $300 million for every $400 million invested for wells, just because of perception, like if you discover a big elephant or a big oil field, then the shareholders will be happy, the company value will increase, and the rest.
If you do it right, you could theoretically recover all of the oil that's down there.
In Kızılorda region, it's 9.9 water and 0.1 oil. Nothing. And still, they are doing it. They're not oil producers, we're water producers, right?
Good day. Welcome to Energy Podcast. Today podcast will be dedicated to the enhanced oil recovery. As we mentioned, it's a really interesting topic, and there is going to be a technical seminar tomorrow and the day after tomorrow in Almaty. I think it's the first seminar that's going to be in enhanced oil recovery in Kazakhstan. Yes? Probably. So there's going to be a discussion before the seminar, and let me introduce my guest on this podcast, coming from very long journey dedicated for this seminar and for this podcast. I would like to introduce Randall Scott, Mr. Randall Scott, Seawright, Professor Randall.
Yes.
Welcome to Kazakhstan. Welcome
Thank you.
to this event. You are Society of Petroleum Engineers distinguished lecturer,
Yes.
and you have more than 47 years of experience.
Yes.
Wow. In enhanced especially oil recovery.
Correct. That's
So you're the
right.
man that has to tell everything about the EOR.
I wish.
You are graduated from in chemical engineering of University of Wisconsin, and you have experience from ExxonMobil, and the New Mexico Tech, where you
Yes.
have been emeritus graduated, or as you said, retired.
Yes.
Thank you for coming, Professor Randall.
Thank you.
Let me introduce my next guest on this podcast, Antoine Thomas. You have 15 years of experience. You are a geologist. You are a reservoir engineer. You are consultant currently, and graduated from University of Nancy. Yeah. You have a book. You have a book on enhanced oil recovery, which is published, Essential of Polymer Flooding Technique, by Wiley Publisher. I think we're going to discuss on this podcast about the book, yes, as well.
We can, with great pleasure.
Thank you. Thank you for coming. And our host, let me also introduce Mr. Professor Marat Sağındıkov. He is the head of Center for Enhanced Oil Recovery. He's the main guy, actually, today, yes, for the event. He's the guy who pushed to do this event, actually. So thank you for this event. Thank you for this podcast. Thank you very much. Because of him, actually, this seminar is going to be in Almaty. I'm really proud of this event to be. And thanks for inviting you for this seminar. I think it's a lot of effort should be done. And with the cooperation and collaboration and support of KMG Engineering. KMG Engineering is a national oil company, R&D center of national oil company, Kazmunaygas. Thank you. And let me also introduce myself. My name is Abzal Narimbetov. I'm a DBA from Geneva Business School and master degree from IFP School. I have 18 years of experience in petroleum engineering, and 3 years my company is Energy Analytics, as well as there is Energy Podcast. We every week, publish a podcast. So Thank you for coming, and let me have opportunity to moderate this podcast. I think we will start with the presentation, yes, Mr.
Yeah.
Professor. So I
Correct.
will like to give you floor to Mr. Marat.
Абзал, құрметті әріптестер, қайырлы күн. Здравствуйте, уважаемые слушатели Energy Podcast. So good morning, good day for all viewers of Energy Podcast, colleagues. I'm glad to be here. Thank you, Abzal, for introduction and minor correction. I'm not professor, so I would like to be, but not. I'm only PhD, so in petroleum engineering. That's a little correction.
Yes.
So
Future professor.
I hope. So let me introduce our event short presentation. So it's a SP Almaty section technical seminar on enhanced oil recovery EOR, which will be held 7th and 8th October, which means tomorrow and day after tomorrow. And our words is calling Accelerate EOR Innovation, Empower the Future, Partner with Purpose. So here we can see current situation of oil production, and I also use it some data from you, Abzal, from Energy Analytics, and we can see that if we can go to the 2025, so you can see the number 93 million tons of oil production, and 2/3 of them, which is a blue Kashagan, green one Tengiz, and purple one is a Karachiganak, is contributing 2/3 of oil production, which is equivalent for more than 1 million barrels per day. And less green one, red one, 28-30 million tons of oil. It's virtually all other oil fields in Kazakhstan, except the 3 big majors. And it's counting about 200 oil fields, which is mainly brown fields, late stage development, where the oil production is declining every year, water cut increasing every year, and it's not stopping. So because of this. Because of these causes and so on, so we can see not nice picture on the right side. So we can see this is a example of Kızılorda region oil production. In 2013, there was a production of 10.6 million tons per year annually. Now it's producing only 1/3 of them. So production decreased by 65% or 3 times. So, and this picture will be same for other oil fields, and it's just a good example to show how water cut and water breaks through and non-recoverable oil reserves can harm economics. And that's why Petroconsol has published that in 2024 we have a we have a less budget, we have a not enough money in a value of 2.6 trillion tenge, which is about 30 or 40% of total budget of Kazakhstan. And that's why we are trying to make our economy through the enhanced oil recovery. That's why EOR is very, very relevant for Kazakhstan. And based on this challenge, it's a very important challenge. That's why Kazmunaygas last year they published their plans for strategic future for 2050. And if you can see, there is many actions, and including green one. We can focus on green one. The green one is the EOR, enhanced oil recovery induced oil. And it's starting from this year, from 2025, and it's increasing every year. So that's why it's showing that it's necessary to implement EOR. Otherwise, we will see cut of this oil production, which will harm our economy. Thus, we started to plan it, starting from first idea. First idea comes to us in last year in April, 1.5 years prior to this day. And it's a long journey throughout 2024, 2025, and we start from concept to planning, and finally we got this picture. So as Abzal mentioned, Kazmunaygaz Engineering is a R&D center and engineering center for national company Kazmunaygaz. And Dr. Rahim Mutiev is a chief executive officer and the chair of the board of directors. Is the chair of this technical seminar program committee. He supported us, and not only him, and all main staff of KMG Engineering involved in organizing this event, and most important, the technical content, which is aimed to solve local problems, not just only talk for talk. Yeah, so the technical presentation, breakout sessions, all aimed to solve local problems in our conditions. Yeah, so as our so we very thankful for our partners and our sponsors. Here you can see the sponsors is major big companies: SNF, Chevron, Lucent Petroleum, MOL Group, Alstron, and others. And also we have event partners as a Kazmunaygaz and Samgao Center for Scientific and Technological Initiatives. So you can see here we have many speakers around the world. So here today participating in this podcast, Randy Seawright, professor from New Mexico Tech, already retired. So we can congratulate you with this retirement. And Jeff Southwick, he is also a PhD in chemistry, and he is a subject matter expert for EOR in Shell. He previously worked there for 4 decades, 40 years, and was involved in biggest EOR implementation in Middle East called in PDO, Petroleum Development Oman Marmul oil field, and they tested polymer flood, then expanded to the full field implementation. They did pilots for ISP flooding, alkaline surfactant polymer flood, which means the improvement of polymer flood. Also, Meshal, Professor Meshal from EOR Center Director from Kuwait University. Antoine Thomas also participating in this podcast. He's an independent consultant. Dr. Liu in Chinese, right, correct pronunciation, but many of them called him Lu Xiaoguang, and he's PhD in petroleum engineering, and now he's a consultant in CC Reservoir company from Beijing, but previously he worked for Daqing oil field, and he very familiar with Daqing experience, and we know that Daqing is the biggest plant or biggest area for implementation chemical EOR. So Dr. Hu Guo or Guo Hu, he's from Beijing Future Petrotech, and also he's a petroleum expert in Sinopec. Also, he's from Beijing, the capital of China, and he will also present the experience in Shengli oil field. The Shengli oil field is very famous oil field, which is his conditions very similar to Uzem field. Some of them condition close to Karajambas field, which is our major production sites. And Hu Guo, his presentation and Dr. Lu's presentation will be very valuable because the experience from the first site, from the first guys, from first viewers who are doing the job at the field, can share with us this very important experience. Also, Almas Aitkolov, he's from Hillcorp, Alaska. He's a chief guy who managing polymer flood in North Slope of Alaska oil field called Milne Point, which is the biggest full field implementation in North America, I guess. And also representative and speakers from EOR service companies, Flavien Gautier from SNF Water Science. So go next. So event will be attended by a representative of relevant ministries, and tomorrow Ministry of Energy's Vice Minister will come, and it will be a pleasure for us to see him and make a keynote speech. And also Kazmunaygaz group companies will come: Mangostammunaygaz, Embamunaygaz, Uzemmunaygaz, Kalamkaz Khazar Operating, and so on. So also operators from all Caspian region, including domestic Kazakhstan, Petrokazakhstan, Caspianneft, TCO, Tengizchevroil, Tatneft from Russia, Gazprom Neft from Russia, also Sakar from Azerbaijan, from Baku, and so on. And also R&D institutes like Optimum, and my Institute of Polymer Materials and Technology, and local universities and international universities like Nazarbayev University, Harriet Watt University campus in Aktobe city, Kazakh British Technical University, University of Oil and Gas from Atrau, Satpayev University, Tomsk University, and so on. So here we collected all experts from around the world, universities, R&D, and field guys to decrease this gap between the theory and practice. So one of the main focus of this seminar will be breakout sessions, which is aimed to solve local problems. So it consists of from 3-4 big parts. So case study holder will present his problems in a presentation forms, 20 more than slides, which he will show what challenges currently they are facing, what actions they did, what results they get, what questions still open, and what hypotheses they have. And this analysis has been awarded to SME, subject matter expert, who reviewed it prior to the meeting 2-3 months ago. So we started as a technical committee members by replying to the case study holder and asking him relevant questions. He will provide the answers for his open questions. And later, it will be group discussions between who participate in this event first time. He didn't see this case study. He will also raise his opinion based on his experience, on his knowledge, and so on. And the final stage, we will do group summary where we will put all our ideas, our discussion results in concise form in protocol or breakout session minutes, in order to save this idea, because we are planning to do this event every 2 years, like SP IOR in Tulsa. And this breakout session minutes will be very important, because after 2 years, we will back and we open these minutes and say, okay, Mr. Who is who, Antoine, you recommended this recommendation, or Randy said, do this lab test more proper, do not use back pressure regulator, or so on. And we will ask, still, are you using BPR, for example? And say, yes, we neglected it. We're not using it at all. We changed our standards. We say, good, so go next, and so on. And finally, we can see the meetings, and most important part is the bureaucracy part. I would like to take a signatures from very important persons. Otherwise, you cannot trigger any budget. You cannot trigger any actions, because anything is doing based on the budget, based on the resources. You don't have money. You couldn't do anything. You just stop it. That's why.
Theory will be just...
Yeah, just theory and discussion useless.
No
That's
practice.
why signature is very important. From ministries, from national company, maybe some operators will say, I like this idea, I will test it, I will invest in this idea, for example. So he will make a signature, and it will be trigger for making further actions. For budgeting. Financial guys, jurisdiction guys, they are very crazy. They say, no, you don't have paper, you don't have signature, go out. I don't care how you are smart enough, and I don't care. Will it be positive for our oil field? I need some document. That's why it's very important. And there is 5 breakout session topics. First will be improving conformance control in brownfields of Western Kazakhstan, challenge and perspectives. Polymer flood. The second one, polymer flooding at a giant mature field in Western Kazakhstan, challenges of scaling up. Third one, enhancing polymer EOR through cyclic surfactant polymer injection, design principle and evaluation. The fourth one, which will be second day, polymer breakthrough, detection, prevention, and production facilities challenges. And fifth one, last one, EOR polymer lab evaluation. What and how needs to be measured. And it's the final slide. So this idea comes not from my head. It's already passed way. So in Russian we call it "Не надо придумывать велосипед." Do not to make a
Will.
wheel. Yeah. Do not try to develop a wheel. It's already have been happened many years ago. Close to century ago. It was a middle of 19th century, and this idea has been led by our first academic, Kanashi Mantayevich Satpayev, who was the first academy president, first academic of Academy of Sciences of Kazakhstan, and he called it traveling sessions. We call it breakout sessions, and during these travel sessions, it has been occurred in first at Ust-Kamenogorsk in 1947, just after World War II finished after 2 years, in order to improve local industry. Guryev now is Atyrau city in 1949, and more 3 more. Then he passed from this life, and then it stopped these traveling sessions. So not stopped, and other academics has continued this tradition, and later it has been stopped. Initiator was Kanash Satpayev, as I mentioned, and format of traveling session is a scientist field visit to the regions to solve local issues in science and industry. So preparation and budgeting start for 1.5 years prior to the meeting. Goal to overcome the gap between the theory and practice, connecting science with the real industry and the needs of the regions. For example, during the Atyrau session, the focus area was the development of oil and gas industry and other aspects, very ecological aspects like a Caspian Sea, including fish resources, oil chemistry, refining, geology issues, infrastructure, railroads, schools, hospitals, and so on. As a result of Atyrau session, the foundation was laid for developing oil and uranium-rich region of Mangistau. So as you know, Mangistau is very rich for uranium and oil, and first oil comes in 1961 from Uzen oil field, later Zhitabai oil field, and big investment in geological exploration started in 1950s, just after this traveling session, and after that, after 10 years, they opened many fields of uranium, oil, and gas, including Kalamkas, Karajambas field, and so on. So we just try to replicate maybe a couple of percentage that academic Satpayev did it before, or just 8 decades before. That's why its idea came from here. So I hope that upcoming event will be fruitful, and we can get a beautiful, very great discussions, and get the roadmap, I guess, or the action list to do, and the recommendation will not stay only on the paper and go to the action in order to improve oil recovery of Kazakhstan, thereby improving the efficiency of oil and gas industry, thereby improving our economy of Kazakhstan. So this is short and long, my presentation. Thank you for your attention.
Thank you, Marat. Thank you very much. So we will start our discussion on topic. Well, the main topic is enhanced oil recovery. It's there. So you've seen just the presentation that the 70% of our oil production in Kazakhstan is coming from 3 giant fields, and the portion of the 30% is coming from the other many fields, and this portion is decreasing every year. 70% of the 3 giant fields is going to increase to 80% in coming decade. So the remaining fields, where the pressure is being declined, water cut being increased, and there is no major, I think, in Kazakhstan, I mean in many fields, enhanced oil recovery ever used. It's mainly water injection and some gas injection. As my understanding, there's some pilot projects on the enhanced oil recovery. So it would be very interesting to have your speech on this podcast, your current ongoing historical, maybe as contextual, what enhanced oil recovery mean currently, what kind of enhanced oil recovery technology innovation being used, and what do you see as a future, and as a implementation, what kind of proposals for Kazakhstani oil field. You have some experiences in Kazakhstan as well, field, and as well as global. So I would like to give a floor to you, Randall, on this topic. To start with, contextually, you have a long history of, history of experience of enhanced oil recovery.
Well, thank you very much for the opportunity to be here. I think this is going to be a great conference. We've got some real experts and a lot of incredible knowledge here, so it should be really exciting. So I think we're all going to learn a lot, and we're going to have a lot of great discussion. So really appreciate Merit organizing this. So that's good. If you like, I could just very briefly say that the general ideas. Enhanced oil recovery is really anything that improves the recovery factor for a reservoir. You mentioned that not just in Kazakhstan, but throughout the world, you got a substantial amount of oil coming just from primary, which means you just drill some wells and rely on the natural reservoir pressure to bring up the oil. And then when that pressure depletes, as you said, then we try to basically repressurize the reservoir, and the way we do that is by injecting water. But there are reasons why we don't get all of the oil. Typically, if we look at the average throughout the world, maybe we might get 30 to 40% of the oil that's down there from the combined methods of primary recovery and water flooding. That can vary over a wide range, of course, but that's kind of the ratio. But it means there's a big target for enhanced oil recovery, maybe as much as twice as much as we've already been produced. And you ask the question, well, why is it that we can't get all of the oil just normally? One of the reasons, especially here in Kazakhstan and a lot of other places, is sometimes our oil are very viscous. They're a lot harder to flow than water, or what we call light oils. And if you just inject water, that water is going to try to take the path of least resistance, and it will not displace that oil very efficiently. So one of the key methods, a couple of the key methods, but one in particular that this workshop is going to be focused on, is increasing the viscosity of what we inject to improve the efficiency of that displacement, something called polymer flooding, which we will talk a lot about, and Antoine has a book on that very topic. It sounds easy enough to just increase the viscosity of what you're injecting, but there are a lot of technical issues with doing that, which make it significantly more challenging and complex than just water injection. And one of the whole goals of this whole workshop and seminar is to identify what those issues are and see where we are and where we need to make improvements and what improvements have been made. And certainly there have been tremendous improvements, especially in the area of polymer flooding over the past 10 years. The basic idea behind polymer flooding, just viscosifying the water, that idea has been around since around 1960, so it's been out there a long time, but no one really done significant activity with that until Dacheng, which was a very large polymer flood. Actually, since then and even now is the largest polymer flood in the world in northeast China. the pace has been accelerating. There has been very great activity in Oman at a place called Marmul, which one of our experts, Jeff Southwell, will talk about at the meeting. In basically 2003, 2004, a very large polymer flood was started in northern Alberta, Canada, a place called Pelican Lake, with a tremendously viscous oil. The oil is somewhere between 1,000 and 10,000 times the viscosity of water. And we are getting really remarkable recovery factors there, up to, I think they've listed 38% of the oil from that. So it's very promising. We're perfecting the technology all the time, and making it more usable, more cost-effective. People probably heard about these methods for a long time, but maybe been afraid of them because of economics. But because of technical and economic advances, we're making the technology far more viable, and that's what we're focused on here in this meeting. So,
Thank you very much. At a decent result, no, like 38% to have this level of.
Well, for
High
such a
viscosity.
viscous oil, that's pretty remarkable. Yeah.
Yes, thank you. Would you like to, Antoine, Mr.
But in addition to Pelican Lake, just to continue, there's been Milne Point, and we will discuss it tomorrow also. So I think if I just have to elaborate about EOR, and then we will come back to it. What's always been surprising to me is when we look at the way we approach oil field production, which is primary production, then secondary, and then very often people associate EOR with tertiary production. So this stage approach means, like, if you are a student and you come at school and you open a book and you read this is how things have always been done, primary, secondary, tertiary, then very few people will try to challenge that approach. But if you look at the results, so the first water injection was in the 1920s in the US, and it's been the preferred method to push the oil because water is everywhere, it's cheap, and we understand basically how it behaves, more or less. But when you look at the results after more than 100 years of water injection, as Randy said, we have just recovered 35% of the oil in place. And so that's, for me, a bit strange to see that as an engineer, 35% recovery seems rather low, on the low side. And so when you see that, the question is, but why we have not changed that? So why aren't we looking at the mathematics that also, as Randy said, we know the principle of mobility, heterogeneity since the 50s with Dijkstra Parson, Aronofsky, Stiles, Dye, and others in the 60s also after. So when we look at that, the question for me is more, why do we keep doing something that doesn't seem to be very efficient? And Randy mentioned the heavy oils, but one of the reasons why we don't recover that much, and it was also mentioned, is because any fluid you inject will follow the path of least resistance. So we know that. And the question is, why do we keep doing something that can be improved? And probably we'll discuss it a bit later, but my approach on EOR is, some people say EOR is early or regret. I think we are exactly there, because the longer we wait, and we will have to pay a higher price to recover less oil. And so if we keep waiting and waiting and waiting and waiting, we know what's going to happen. We have 100 years of experience. We will have very high water cut, early water breakthrough, and then we need to spend just more money to make it work. And I think it's starting to shift a little bit, not in major companies, but in companies like Hilcorp, for instance, who have found a way to go much faster from the idea to the implementation and seeing the results, which are really amazing.
Actually, I have met a representative in Hilcorp in Houston during the Ryder Scott Reserve Annual Conference, and they've mentioned about their substantial increase of oil They are buying very mature fields, and they're managing assets to increase using the EOR methods. Yeah. Thank you for mentioning it. Would you like to add?
So they're calling themselves a champion of mature oil fields. So Hill Corp, they calling themselves. Yeah. So they make acquisition of old mature oil fields and improve oil recovery. So one point to that about Milne Point, they have about 50 injectors, right? 50 injectors, horizontal injectors with a length of horizontal part of the well, I guess 2,000 meters, something like that. Yeah, more than 1,000 meters, 1 kilometer, and most of the injectors, so injection, more than 90% under polymer solution injection every day for years and years. So it means they're doing polymer flood in a full field scale just in 5-6 years. So starting from pilot in 2018, 17, and now is a full scale, and they injecting about 60,000 barrels per day of polymer solution, and they're recovering, and they're doing very good work. Some of the pads they have improved recovery. They have recovery factor about 20% with zero water cut. Can you imagine it? It's very remarkable results. So they just break the mold, as Antoine said. Let's do first very bad things, because we write it in the book. We should start first from primary, then go to secondary, because it's written in the book. Then we make a bad condition for the reservoir. We make water break through these channels. Then we will go to tertiary, when you cannot recover much as you start from the beginning injecting polymer solution. So they break this mold and just doing polymer flood as an industry standard. So it's normal for them just to do it from day one. For our mentality for Caspian region, it's a little bit tough, and people couldn't believe in that. Say, how it's possible? I need to do very bad things first, then go to wonderful EOR, which will solve all my problems. It's like if we do make comparison in simple examples, it's like human life. If you living from starting every day doing stretching, doing sport, eating good food, not drinking alcohol, not smoking, you will have a very good future in 70s, 80s age old. You will have not the problems. And in contrast, you have a guy who dancing every day, going to nightclubs, drinking every day, smoking. At 60, 70, he will be in big trouble. Still, he will be alive. But in contrast with that guy, it will be not.
If he's going to be alive.
Yeah. So it's very simple examples which shows we should do not tertiary, we should do primary with the EOR just directly.
And about in historical context, what is the percentage, or maybe like in qualitative information, like 50 years ago when the EOR, been started? Currently, the share of the primary, secondary, and the EOR implementation globally, or maybe it depends on the regionally. Your opinion, Randall?
Yeah, certainly historically a good 50% of our oil has come from primary production, and we certainly, as everyone knows, people are always looking for oil and finding better ways to find the oil in the first place. And then, maybe that number is closer to 40%. Maybe 45%, and then a similar amount is coming from water flooding. So those are really still the two methods that have been the greatest. And enhanced oil recovery has been, as Merritt had indicated, a relatively small fraction. Maybe 10%, maybe even less than that. But the whole goal of this conference and us sitting around the table, our goal is to improve the technology to the point where we can substantially increase that, and we are making real progress on that. So that's a key message to make, is maybe people just historically have said enhanced oil recovery has not been a big contributor, but because of substantial technological advances, we can really improve that in a not too distant future here. So.
And in terms of recovery as well, I think there's been a huge increase, yes? I mean, what is the biggest number in recovery factor, in your experience, achieved using the enhanced oil recovery? Or maybe globally?
Yeah, there is in a particular field. That can vary over a pretty broad range, but just to use the example of Milne Point, that might be attractive to a lot of people. The first polymer injection pilot they had up there, they had injected about a 10% pore volume bank of water, and this was, in this particular pattern, it was about 300 centipoise oil, about 300 times the viscosity of water. They started water injection, and really within 2 months in the offset production wells, 1,500 meters away, they would get severe water breakthrough, and their water cuts would go basically from 0 up to 70% water cut in a very short period of time. And as Merritt had indicated, they started polymer injection in 2018, and really over the course of the next year or so, they decreased that water cut in the offset production wells from 70% down to less than 5%, very close to 0, and it maintained that value for well over a year period of time. And to my knowledge, that's a larger drop in water cut than any polymer flood that's ever been applied. So it makes the point that we really are making some serious advances in how to apply polymer flooding to be effective.
Increase. Almost 0. About your experience, Antoine?
We say very often the extra recovery factor from polymer is around plus 10% original oil in place, ranging from 7 to 18, sometimes 20, 22% in some cases published in some patterns in China, for instance. But if you look at Argentina, and you might see the graph on LinkedIn published by some people from the country, you see that starting from 2019, the oil production in the country was something like 2,000 barrels a day. And in 2024, it went up to 16,000 barrels a day, multiplied by 8. Yeah, just with polymer flooding in mainly from companies like YPF, CAPSA, and others coming on stream like Pan American, for instance, Pecom and others. So this is huge, and it's been the case in Marmoul. I mean, Marmoul, for instance, the first polymer flood was in the 80s with amazing results. I think it was, if my memories are okay, 25% extra oil.
Marmoul is in
Oman. It's in Oman. In Oman, yes, south of Oman. So globally speaking, it's between 8-15%. We tend to say 10% OIP, but that's in tertiary mode. So that's after water injection. What we probably will see with Hillcorp and others, and Pelican Lake was one of them, but also Bankers in Albania, is, of course, if you start earlier, just looking at fractional flow equations and the rest, it will work much, much better, and it works much better. We already see it in Alaska. So, yes, in the Prudhoe Bay area, yes. So this is the kind of average we expect. But in addition to the oil, as Randy was mentioning, you delay water breakthrough. You delay the volumes of water you have to handle. If you look at another project, for instance, Captain offshore in the UK, they have accelerated the oil production by 6 years. So the water estimated ultimate recovery was expected at a certain date, but polymer flooding has brought this value 6 years before. And then some extra oil that the water would have never recovered in a timeline where it would have been economically feasible. And in addition to extra oil, what they have seen is a large decrease in water cut. So if you leave the pattern, so to speak, 6 years before, then you produce less water to treat, to re-inject, to dispose, less HSE risks, because you don't operate the same way if you can accelerate this production. So that's really the combined effect of delaying the water handling problems with accelerating and increasing the total recovery. So that's why the earlier you start, and it's very likely that the timing is always key. The timing is key everywhere in every part of life. So there is no exception, I think, to the oil industry.
Wow, that's a magnificent results, like 8 times increase in Argentina, as you mentioned this. And I think there's also in Kazakhstan fields being implemented. Yes, some you have.
Yeah, we
experienced.
Yeah, we experienced it in EOR. So, on my personal opinion, we have substantial, remarkable experience in EOR, especially in polymer flood. So starting from 1980s, on the early 1980s, where polymer flood was not so major as today, and it was a Kalamkas field at that time. They injected polymer flood in 15 to 20% of all injectors. So it was some of the reservoirs was under polymer flood in the full field mode. So total it was 50 injectors, vertical injectors, and couple of hundreds of offset producers. And they increased it additionally more than 7-8 million barrels of oil additionally. So it was substantially improving the recovery, and they use it as everywhere, hydrolyzed polyacrylamide, HPAM, and it was at that time it was expensive, but still it was viable and feasible. But unfortunately, we know all that Soviet Union has faced many problems in late 1980s, which has been laid down to stop the Soviet Union, separate the countries to called now CIS, independent, how it calls, I don't remember. So now it's Russia, Kazakhstan, and so on. So at that time, Soviet Union time, Kalamkas was a pioneer in polymer flood, and it stopped in late 1980s, I guess in 1989. No, not looking at, because the state was cannot be survive anymore. That's why it stopped. So because of economics of the whole country. Then passed about 20 years, like that, new life come to polymer flood at the same field in Kalamkas in 2014, and the same time they started other projects in Atrau, in Emba, called Zaburunya, and in Kazgermunai, called Nurali. And I was in charge of implementing polymer flood in Kalamkas field, and it started as 2014 in two injectors as a pilot called West. So injectors 2041, 2049, and they increased recovery up close to 10%. And now the challenge was polymer flood, although polymer flood not new technology for Kalamkas field, but the implementation time frame not same. So at the time, they was using as a primary production and secondary. They didn't inject the water. They have some patterns with primary water injections and then switch to polymer flood. But most of them just directly started from polymer flood, injecting the polymer solutions. They knew that the high viscosity of oil, at least 20 centipoise in reservoir conditions, and they knew that if they inject the water, it will be terrible polymer breakthrough, water channeling, and they just started from injecting polymer solution. Of course, at that time, there was not so major facilities and surface equipment. At that time, no nitrogen blanketing unit, no PSUs, no polymer injection units. It was, not so modern units as now. And still they have substantially increased the recovery. And up to date, it has been passed from 2014. They started with new equipment, modern equipment, which is saves the polymer solution from chemical degradation, from mechanical degradation, and we did a very good job on investigating these issues. And my research was focused on polymer stability, and especially in mechanical stability and chemical stability, and we proved on the practice. So previously many researchers did their research based on the core flood experiments, based on assumptions, simulations, and so on, and many few done real practical investigation on the real injectors and producers in the field. So we did some experiments on our injectors, producers, and proved that there is no mechanical degradation, because vertical injectors, where inject high viscous polymer solution, will naturally induce the fractures, which will benefit inject polymer flooding to accommodate the all polymer viscosity, eliminate mechanical degradation, and improve injectivity. And another one was related to super highly condition of reservoir where you inject the oxygen. It will very high consuming condition, where if you inject the oxygen with a polymer solution, it will be consumed very fast by the surrounding rock because of iron containing minerals like pyrite and siderite, and it also helps to improve viability and feasibility of polymer flood. So we did great job, and I can say that Kazakhstan science in polymer flooding is also in a good position. So we have experience, and many researchers from outside, from Kuwait, from other part of the earth are citing our work, and not just citing he's a stupid guy, he did bad work, but they say, look, Kalamkas field proves that there is no mechanical degradation. So I remember one work from Mangala field, they cited us and said we will try to do same technique, and they also proved that there is no mechanical degradation after our publication in 2022. So bottom line of my words is that we have a huge experience in polymer flood, in conformance, gel conformance, and other EOR technology, and we have a lot of fields which needs this technology. That's why doing this seminar on enhanced oil recovery here in Kazakhstan is highly important, highly relevant to this region, and we can expand our experience for our neighboring countries, like friendly countries like Russian Federation, Azerbaijan, Uzbekistan, which also needs this one. And adding one point, now, as I said, we have huge experience, and Russia will start soon full field polymer flood in East Mesayaha, and it will be biggest project in post-Soviet Union country. Previously, we were biggest project in post-Soviet country. Now, Russian Mesayaha field will be biggest one.
Just to elaborate on Merit's point, so people get the point. Like I mentioned, we have had really substantial advances over the past, especially 10 years. And as you can imagine, if we're going to do a polymer flood, we spend a lot of money on polymer, and we want it to be effective and stay effective in the reservoir. I mean, it needs to be stable as it's traveling through the reservoir. Now, before about 2010, our laboratory work had said these are the conditions when polymer should be stable, and this is where the conditions where it would not be stable. But people have gone into the field and tried to determine was the polymer stable or not. Like they would produce the polymer from a production well, or maybe they would produce it back from the injection well where they put it in. And in the vast majority of cases, really most cases, what they observed was that the polymer had experienced really severe degradation. But if that was the message, well, then you would say doing polymer flooding is crazy, right? Because if it's all degrading, that doesn't help you anything. So our concept, then we had a discrepancy between the laboratory, which said it should be stable, and the field measurements, which said, well, it's degrading, right? And that's going to be discouraging to big managers, right? Because you're spending massive amounts of money on polymer. And a big contribution from Merit was our hypothesis was simply that the reason we were getting a negative result in the field was because of our testing methods, our methods of collection of the polymer and then actually testing it. And we suspected that what we were doing was simply the process of degrading the polymer, and the real polymer was stable in the field. And a big contribution that Merit did was to demonstrate, to develop a method to actually collect those materials properly and demonstrate that there both was no mechanical degradation or shear degradation of the polymer, and there was no thermal or oxidative degradation of the polymer as well, if you do it right. I mean, it was critically important that you remove oxygen, as Merit had said. But like I say, that is an advance, because if you're an operator, you'll go out in the field and your natural tendency is, well, let me do the cheapest thing I can. And a part of what we're doing is learning what is important, and you have to spend the money to get right, and what things are not important. And Merit had done a great job in demonstrating, yes, we absolutely do have to get rid of the oxygen, and yes, we can get it into the reservoir and it's perfectly stable. So those are major contributions just in the past, like I say, 10 years that show us how to do this technology correctly so that we can make a bunch of oil off of this thing.
So basically there is like a gap between the laboratory and field testing. So we need to somehow...
Yeah, that's an excellent point, because we do sometimes have a natural suspicion between what the field people are doing and what they see, and then they maybe might be suspicious of laboratory people that maybe we're not doing the tests correctly to reflect what the polymer is really doing in the field. So number one, we both have to talk to each other. We have to be aware. The laboratory people have to be aware of what the field people are seeing, and the field people really need to be aware of what the laboratory people are discovering and making useful. And one of my philosophies, I do commonly get field people tell me, well, what we see in the field is not what you see in a laboratory. And I think the truth is that what we see in a laboratory is correct. What we see in the field is correct. What we do with our basic petroleum engineering principles is correct. All three of those are correct. The only thing that's wrong is our interpretations. So what we need to do is put them all together, realize that they're all of value and valid, and find out the explanation for what we're seeing. And that way we can make truly major advances and make the technology work much better.
So it's like combination of all the things. About the economy of this, as you mentioned, it's not cheap. Well, it's expensive maybe. Maybe the primary and secondary and the tertiary or enhanced, they're not the same. The first primary is like the cheapest one probably when compared. Well, depends again. What will be the economy of the scale of enhanced oil recovery projects, and as from global experience?
I'll probably answer the questions in two ways. The first one is a straight one, which is how much does it cost? So typically when you look at, I would say, conventional polymers, so when temperature is low, salinity is low of the reservoir, typically it's between $0.7 to $1.3 per barrel extra. And if you add the equipment and the facilities, anywhere between $1.8 to $2.5 extra dollars per barrel onshore. Depends on, you can have some extra drilling and the rest, but that's typical. And so what you see is these kind of projects, they break even at 2 to 3% extra oil recovery, extra OYP, which is not much. Because I said before that basically the typical recoveries are in the range of 10% or more extra OYP. When you do things well and you are not at the very late stage of the oil field production. So it breaks even very fast, and the rest is basically pure cash. And the less you wait, and the more money will be made for sure. Now, when it comes to cost and you compare to primary, secondary, tertiary, I think it's a mindset because today, for instance, when we do EOR, we know the oil fields, we have the infrastructure, we have the facilities, we have drilled wells, we pay people, we have reservoir models, we have acquired 3D seismic, which often has cost 10 or hundreds of millions of dollars where you are. And you leave the oil field with more than 60% of the oil in place. Half of it can be recovered. So in the end, you spend a lot of money and you leave like there is a lot of left. And when you compare what's happening today in the world, so people, for instance, say EOR is expensive. But look at, for instance, the offshore exploration these days, where people, the success rate like in 2023 was 20%. So out of 4 wells drilled, 3 are dry. And this cash is just, there is no salvage value, it's written off. So it means that the manager who says EOR is expensive agrees to lose $300 million for every $400 million invested for wells, just because of perception, like if you discover a big elephant or a big oil field, then the shareholders will be happy, the company value will increase and the rest. But we know that it will fail 3 times out of 4.
Yeah. Success rate. Yeah.
And so if you look, they say, yeah, okay, but you don't compare the same things. I'm comparing oil. So there is oil in existing oil fields, and there is maybe oil in exploration. And so in the end, if you look at reserves and oil, well, there is oil and reserves in existing oil fields. And if you fail a polymer flood, it's just an expensive water flood. If you fail a well, there is no salvage value. It's like the cash is gone. So in the end, when you look rationally at the data and statistics, if you look rationally, that's my point. If you look rationally, when you have less risks to do EOR than to go look for smaller Easter eggs because the big ones have already been discovered. So my conclusion when it comes to EOR more and more is there is something which is really not rational. It's like people like drilling, they know how to drill, there is a hope to discover, there is a chase for the big guys and the rest. And they think that polymer flooding is expensive, or also people say EOR takes a long time to get the benefits. But how long before discovery and first oil? So we can make a project, an EOR project, work in 3 to 6 months, depending on spacing and the rest. I would never make FPSO in 6 months. It's
6 years.
Yeah. So that's why the perception of risk is very different where you are, but the results are here. Like you see the losses, you see the benefits. That's why I think in the end it comes to something. Technically speaking, as Randy said, everything have improved so much, and even people in the US say that if you want to make polymer flooding fail, you have to put energy to make it fail. And I think we are at that point. So the fact that people don't consider any EOR technique, given what we know, like if every reservoir is heterogeneous, the water will follow the path of least resistance. So the question is when you will have the problem. You will have the problem. The question is when. So when you know that, the question is why do you keep doing something that you know will fail? You just don't know when. But like 100 years after the first experiment, that's where we are. So that's why it's more complex than just technical aspects. It's like
there's no one answer.
No, there is.
But in Russian we say that it's better to have your you have something in your hand than looking at something in the sky, which is not reachable, but you just dream about it. So huge elephant wells, big fields, fields. Agree. There is a step by step, small risk but small trophy. There's a big risk, big trophy. It's not the same thing. It's comparable. And this term as well, the economy of the scale. Some people say that enhanced oil recovery. In terms of the there's a very very famous words now used, like sustainable development, sustainable carbon footprint. So in terms of these, and enhanced oil recovery is not the first time, being implemented. And from your point of view, to explain to maybe our participants of this podcast that it's a clean and it's a viable and sustainable way of also recovering the oil or gas.
But maybe so the reason, so we need energy to recover energy. Yeah. So when you look at oil, for instance, the question is how much energy do you need to get this oil out? The problem is when the field matures, as we said, the water cut is increasing. So in the end, then there is a paper from Shell, from Faraz Jaleh on this, for instance, about the carbon cycle of oil fields. You see that when the water cut reaches 86%, the exergy, so the useful amount of energy you spend, is going exponential, same as the CO2 emissions. Why? Because the pumps and everything is everything is turning to produce water. So you just burn energy to produce water. And so if you want to decrease the CO2 emissions at the same time and get the oil out of the ground, so not discussing what's going to come after, but just this part, the easiest way is to decrease the water cut. Because, you don't want to produce water, you want to produce oil. And so how do you reduce the water cut? You have a lot of strategies, but one of them is what we call conformance treatments. Polymer flooding is a strategy to address conformance, which is to slow down the velocity of water in the reservoir and produce less. So you have the approach where you have to fix that, which is now, like there is high water cut everywhere, and you want to decrease it. Or there is the other approach, which is if I start early, I will delay the moment when I will have the problem. So there is prevention and there is cure. And today, I would say unfortunately, we are in the stage where you have so many brownfields that you are in the cure process, which is I have water, and we will discuss during the seminars, like everyone has a water cut problem, and we tell you, yes, fix my water problem. But okay. But so that's again the same rationale behind, which is maybe it's too late to fix, or if you want to fix it, it will be so expensive that no one will
preventive methods. Early time is better than you just extinguish the fire, something like.
We're all firemen, yeah. Solve my problem, do a magic. There is no miracle.
And there is a lot of, there's a lot of methods, not only polymer, in enhanced oil recovery. There's other methods, and historically being used all methods maybe, but currently just for the podcast is for everyone. So like in definition term, maybe you just share your experience, the type of the enhanced oil recoveries, and currently maybe the most used ones globally.
Well, certainly historically, thermal recovery was one of the most popular that took off early on. And the idea is if you have a very viscous oil, super viscous, then if just by heating it, you can dramatically remove or reduce the viscosity of the oil and make it more flowable. So that was certainly one of the techniques that took off fairly early, and has been to get that heat into the reservoir. Injecting steam has been probably the dominant method, and has been very successful for a number of reasons. And a second one along with that was something called in situ combustion, which means you just basically start a fire in the reservoir. You let the fire generate the heat to reduce the viscosity. That's certainly a far more complex technique and much more difficult to get to work. But steam has certainly been a big process that has been popular for quite some time. There are certainly reasons why steam has not been successful, and why polymer flooding is starting to take the place of steam, especially if you have a relatively thin layer or reservoir. If you use steam, of course, you're going to have heat losses through the upper and lower boundaries of that reservoir, and in that game in steam flooding, heat is money, right? So the more efficiently you can utilize that, the more cost effective your process is going to be. So thermal recovery has been most effective in relatively thick reservoirs, but a lot of the thinner reservoirs, which we have a lot of, Pelican Lake, Milne Point, Tamburejo and Suriname, a lot of places, steam is just not viable. Also at Milne Point in particular, that's on the north slope of Alaska, and they have what they call permafrost, which means the ground is frozen. I'm sure that's true in Siberia as well, that if you start injecting steam, you're going to have a big mucky mess that you have to worry about. So this is a much better alternative for that. Another process that had been quite popular, and a lot of folks, especially in the environmental area, are interested in CO2 flooding. And the idea is you inject compressed CO2 to the point where it's what we call supercritical, or basically you compress it to the point where it's effectively a liquid and in fact a solvent that will actually dissolve the oil. And that process has been quite effective in West Texas in the United States, a few other places. There's been a lot of hope held out on that with the interest in carbon sequestration, that if you just do normal carbon sequestration, that's a very expensive process. If you take CO2 out of the air or out of some burning gas and then try to inject it, you don't make any money off of that. That costs money. And the whole idea with the CO2 injection, using it as a solvent to dissolve the oil, is at least you can recover some oil and make some money off of that. So those are two processes that have been quite popular, and I think both are really kind of declining a little bit, and polymer flooding is taking over in places where we have a better place to do that. Another technology which we've been trying to develop for quite some time is what we call surfactant flooding, where you put a surfactant in, and the idea is to try to, I'm not sure everybody will understand it, but you reduce interfacial tension. Basically, you're trying to make that water into a solvent for the oil. Of course, we know water and oil don't usually mix, and you're not going to do a good job of dissolving the oil with that. But with the surfactant, you try to get closer to being in a position to do that. And then other people will do a modification of that technology called alkaline surfactant polymer flooding, or they abbreviate that as ASP flooding. And it's basically trying to do the same thing, but they try to make the surfactant maybe cheaper and more effective by adding a basic agent like sodium hydroxide, sodium carbonate, or some other really basic material to try to improve that. That technology's been challenging. There are always been a great number of technical hurdles to that. It's necessarily an expensive process. The good thing is if you do it right, you could theoretically recover all of the oil that's down there. But that has been something that's really still under development. It's not taken off anywhere near as much as steam flooding, CO2 flooding, and now polymer flooding.
It was really comprehensive way to understand the enhanced oil recovery, all the methods. About the people now, experienced people, enhanced oil recovery. There is in Kazakhstan, a knowledge and experience gap between the veterans of the oil and gas industry and the new generation. We've been through this independence, and there was oil and gas industry was a little bit far from the outside. how this knowledge and experience gap to be solved these days, because there's a big experience from the veterans of the industry, and to transform this experience knowledge to the younger generation, because there's less and less people, I think, especially in Kazakhstan. I don't know in the global term how this gap to be shortened, or the gap to be reduced.
Well, there's certainly two sides to that. When we get really old people like me, we get maybe stuck in ideas and think that things can only certainly be done in a certain way, and maybe we don't appreciate that new technology really has been developed and really big breakthroughs have occurred. The nice thing about the young folks like Antoine and Merritt here is they're very enthusiastic, much more willing to consider new ideas, much more willing to read about the new things that have happened and apply them in creative ways and make big advances. So that's really kind of an encouraging thing. It is certainly important for the new guys to say, let's look back at what has been done before, as was mentioned, that we don't reinvent the wheel, but a lot of times it's a good idea to take a good look at the old wheels and see if we can't make them better, which is what is happening right now, which is really very encouraging and exciting. It's really satisfying for me as an old person to see guys like Merritt and Antoine and others to have such enthusiasm, have such great understanding, and picking up ideas so well. And that's another goal of this workshop too, is to make those points, see where we still have problems, where the new guys can come up with creative ways to come over those, and see where the opportunities are. So I think it's a really exciting time for us.
Thank you very much. Sharing is caring. So what do you think, Antoine? I mean, you are represented from the, with the biggest experience, but from the, your generation, this hypothesis, does it seem to be true?
No, I mean, I agree with Randy, but Randy also said a lot of time before that it's important to read, which is not to reinvent the wheel, but to have a look at the different ones. So we always say that if you want to break the rules, you have to know the rules first. So the idea is to read what people have done, because a lot of things have been done. But personally, what I try to do is, does it make sense now? So for instance, when I looked at this primary, secondary, tertiary, you look rationally at the data, you say that there is something that doesn't look right. And the idea is, okay, so if I know this, now I need either the flexibility, the people or the companies to expand on that idea. So it won't work with everyone. It's like in AI, startups and the rest, you will have the early adopters, you will have the laggers and the rest. But some people, when they see the potential, we mentioned Ilcorp and others, they just go there and they try and it works and everything is going well. So for sharing, for instance, that's what I'm trying to do is we're doing a podcast today. We have papers, books, conferences, trying to digest the knowledge and to share it with people. So I think that's really key. The challenge still is, we are working in an industry that's been doing the same things for I don't know how many years, how many decades. So if you come very happy and joyful, want to change the world, you know that you might hit a wall, but not everywhere, not with everyone. So the idea is to keep pushing and say, okay, if what you think is making sense, then at some point it is going to work out. Try to share, try to explain why you think what you think. Try to write about it, and it might work. Where I'm a bit more concerned is more or less the number of people who will remain in the oil and gas industry in the next decade, because we've seen it in the last week. Again, the big guys are firing a lot of people, ups and downs. So it's not helping I think it's not helping for the long-term strategy. It's not helping people to be willing to stay in the industry, because if you're afraid that you have to reapply for your position every year, every 2 years, like it makes no sense. So where I'm a bit afraid is what will be left of this in 10 years. And I see a bit the French history of the nuclear industry, which is we had something amazing in the 80s starting. Then for a lot of reasons it stopped. And now that we need the expertise in the people, but there's no one, there's gone, because we didn't train anyone, and we have to catch up with other countries who kept developing these technologies. And the oil and gas industry is wherever you look. Well, I mean, however you look at things, we might still need some just for the petrochemicals, for some other stuff. But the problem is, well, if you fire everyone, they don't want to come back, you don't train people, you close the petroleum engineering departments. In 10, 15 years, it's like we will probably need something, and we will have to reinvent the wheels and the skills and to find the people, and that's... And so this, again, this is a kind of thing which is a bit, I would say, strange to me, because the idea is when you look at companies, they are normally looking at the long term. Everyone wants to be there in 100 years. But the way things are happening and the way some companies behave, like firing, hiring, I think is not helping. So yeah, we'll always find people, we'll always have enough. But starting and when you play with fire, at some point you'll get burned. It just when it's like the water breakthrough issue. Just wait a little bit and you will have the problem. So, and yeah, I think we're gonna get there. Unfortunately, for
at some point there won't be a returning point.
Yeah. I think we're getting there.
Just mentioned about this AI fancy term again nowadays. What do you think? But some companies just explain that we shorten because there is automatization, there is like AI. I mean, how it's true that this? I mean, because of this.
But my experience, so I have the chance to work with a couple of software tools using AI. But when I discuss with the geniuses behind these tools, they tell me that AI has always been there. It's just most of the computing power has changed. I am a ChatGPT user, for instance, and sometimes it's hallucinating. You have to double check, triple check for important things. So I don't say it's not helpful. Is my point of view is right now the way we are in the industry, I think it will be very helpful for a few things, because AI, for instance, is very good at finding patterns. For instance, imagine you have thousands of wells and you want to find trends in water breakthrough. AI will be amazing at clustering, finding patterns, and telling you where to look. But there might be other things where, if you need a teacher, the results will be the results of the teacher. It's like in simulation, garbage in, garbage out. So then if you have many teachers and you can find the substance within all this, there is a chance, and I think it will do a lot of great things. But in some applications, it will just not... It will not help. We also always joke like the only things it will not help me with is to repair the bathroom and to win an argument with someone I love. It will not. AI will probably not help. So for the oil industry, I see applications. There are a lot of good ones. I don't think it will do everything. I don't think we're there yet.
Yeah, we're not up to this point. And it was in the this famous forum that Ryder Scott annual conference was in 2 weeks in Houston. I participated first time as a person, and there was a first time I see a session by NVIDIA representative, and he was in his presentation trying to explain that at some point like engineers will be replaced by computers. I mean, there was a lot of people listening this session.
Right.
Yeah, I mean,
Not computers.
not robots. I mean,
Computers listening computer.
I mean, as you mentioned, I agree that actually the software like Petrel or Intersect, I mean, they were like a lot of times ago. I mean, this is actually a part of computation. I mean, computation is being faster and faster every day, but still the users are people. I mean, users who decide, propose solutions to the problem. And instruments will maybe accelerate, but not replace. Because, I mean, there's a human who can decide and select which one is as an option.
The only thing I see where there would be an advantage is when you can remove the human bias. Because when we take a lot of decisions in geosciences, you can look at seismic interpretation, analogs, and the rest. This is really interpretation. And if you give one model to 5 different people, you'll come back to 5 different answers. But when we have data, what there is in the data, it's there. You can't cheat. So the only thing is how you reveal what's inside the data. And there you have amazing algorithms and ways, what we call unsupervised, that can help with the supervised approach. Because supervised means you have a teacher and you are looking for something. But unsupervised means like you take what there is, you take out what there is. And I think combining both is something that will really help decision making. If we can, it won't apply everywhere, but if you can apply more mathematics to more bias approach, like the view of the interpreter or someone who knows where to look for, but sometimes, you see things that don't exist just because you've been trained to see them. So that's why you need probably to have a...
Yeah, I agree with everything that's been said there. Just as it was explained to me that made a lot of sense was, as Antoine said, the AI can be really good at finding trends really quickly if there is a trend. If there isn't a trend, it'll still find a trend for you. But what's a good rule of thumb that was explained to me was, okay, let the AI find a solution, but if you can't understand the solution as a human, it's probably not a solution. It's probably, as he said, a hallucination. And once you see it, us as humans ought to be able to understand it and learn from that.
Good point. Great point.
Yeah, great insight about current trends. I think that, as you mentioned, being not only timing is a quick implementation. Being, not only on timing right, but quick implementation of any method for reservoir development. And I think the challenges, in my opinion, locally and globally, we have a lot of bureaucracy in Kazakhstan.
Everywhere. No worries.
Everywhere. But what I find in the biggest increase in oil production in United States, US, was because they're quick in implementing hydrofracturing, a lot of multi-stage drilling. That has been a little challenge, I think, in terms of the Kazakhstan, because our production is quickly declining. If you remove these 3 fields, it was 42 million tons. Now it's 28 million tons. And after 20 years, we're expecting 10 million tons from this 100 fields.
3 times less from today.
And the biggest challenge is that we have a regulatory, barriers. Everything needs some kind of approval, some kind of stage pilot, then you
board
need to
directors
by
and
road.
so on.
Yep.
Yeah.
In terms of this, maybe Marat, you are you are really down to it. Can you maybe share your experience, the challenge that how can the current challenge that Kazakhstan have from the regulatory perspective, and how can this be? Lessons from globally, and how to make this quick. How this challenge to be.
Yeah, very good point. Telling the truth, I don't know correct the answer because it's really tough question, and I have only ideas how it can be solved. So if you can see, if we look at the US, where we have a good example of success, big success story is the US. All oil companies is private companies, without state shares, and it have independence, and it's really market playing on market rules. If it's feasible, if it's viable, they expand, they do actions, they take more oil, more actions, more value, more output, more money. But in our case, oil industry, unfortunately, not playing on the market rules. and we still have a mindset of Soviet Union time. So it's a like social country, because we, as we mentioned, even if AI, for example, can replace the people, we would not do it, because people should go to work, get the salary, and feed their families. This is a problem. And another problem is related to our inner market, yeah, because except these three majors, Kashagan, Tingizere, Karachaganak, all these 200 oil fields and maybe 100 companies, more or less, should provide the produced oil to inner market in a share of 2/3, and only 1/3 or little bit more, little bit less, can be exported to outer market, yeah, to the global market, where the price is really much higher than inner price.
Twice.
Yeah.
Yes, to export.
So we see, we can search in Google Brent oil price, I don't know, now $70 per barrel. So in our country it will be 30 $30 $30 per barrel. So it's not feasible to do it, but we still supply it, because we have our
requirement
and the pressure from social part of the country.
Because there is a demand for the petroleum products.
Yeah, so for oil, for gasoline, for benzene, and the government, I can understand them, because they couldn't increase the price for oil products. Otherwise, the people couldn't buy it and make their life how would say feasible here. And it's one point is economics. So it should be viable. That's why Kazmunaygas, with collaboration of Ministry of Energy, developing new regulatory related to mature fields for late stage development. It's like a project. I heard about them, but I didn't see, because it's still not have open access on this, and it's under developing. They proposing to give a chance for oil operators, if they implement new technology and can recover additional oil, they will be allowed to export this amount of oil to the global market. And another rule is related to taxes. So they will have a cut taxes because of implementation of EOR. And it's also have a second half of the, we call it in Russian, вторая часть палки. Второй конец палки. So the second part of the stick. Yeah. The first part is hurt. It hurts like, oh, it's good regulatory, good law. It should help to improve recovery. But we see Carter's law in 1980s in US, where he cut the taxes. He called, how it calls it?
It's a windfall profits tax.
Yeah, windfalls profit tax in 1980s, when they want to encourage the oil companies to do EOR, and they did not good job. They just inject polymer just for EOR. It was very small volumes, low concentration. Nobody cares how it reflects. So is there any additional recovery? They don't care.
Just get the tax break, and that was big
just
money for them.
Just
right?
take the taxes cut, and they didn't give the good results. And they understand that it's not good way, and they stop at this rule. So
and that hurts the technology too,
Yeah.
because it gives the technology a bad name. Right?
yeah, the technology is good, but because of this tax reduction, they said it's close to unreal. It's like, sorry for my words. They said it's bullshit, and it should.
Reputational.
Yeah, it's reputational risks, and I very like initiative from Ministry of Energy and National Company of Kazmunaygas. We should do something, and I think it's a good approach, but we should understand, we should put the rules of play of this game, how they can prove that it's really EOR, yeah? Or we should find other approaches to do it. So as I mentioned at the beginning, I don't know the correct answer because I'm more technological guy than political and regulatory, and I would like to give this competent and very important work to who has competency and experience, and one hope is that they can include the experience of unsuccess story of US when they have this tax reduction and and didn't help, and more it hurts the technology. So it's the main point of related to this expanding and scaling up this technology.
Well, one positive thing is, one of the things about human nature is as you say, there can be regulatory or social or whatever hurdles that says, okay, you shouldn't try something new because you're not wise enough or old enough to do that. And when you think about some of the big steps that have been taken, it's been by people who said, I believe in this and I know what you're saying, but I'm going to try it anyway. As you had indicated, Mitchell Energy said, okay, people are saying horizontal wells and combined with fracking. Who would be crazy enough to go out of getting oil out of shale? And he was bold enough to do it and to make a big difference. I mean, you could even say that's true in polymer flooding. In the mid-1990s, we had just gone through that period where this tax situation in the United States, people had very cheaply and inappropriately applied a lot of polymer floods, but done it in a very bad way. And at that, by 1990, the philosophy in most of the world was chemical flooding, polymer flooding is stupid and you don't want to do it. And China said, look, we think this could work. We've got this big national resource. I know what you're saying, but I have confidence that this can work. And they did it, and they made a major step for us. So, a message for the younger folks is, don't be afraid. I mean, you do have to understand the fundamentals and you have to understand what you're doing, but you can make a big difference just by yourself. Maybe become a trillionaire really quickly here. So there is definitely hope for that.
In local currency, tenge.
Yeah. No, I'm not talking about that.
Trillionaire is easy.
I'm talking about dollars. Yeah.
In terms of dollars, that's
sorry.
a huge.
I got to get my context right. Yeah, good
I
point.
like this. I would like to be a trillionaire. And I will do you just for fun.
Everyone is. Yeah, that was really interesting. Discussion, and there's a lot of insights you've shared, and the current industry, and in the past about the EOR. What would you expect for upcoming future, like 5 to 10 years, in the area of enhanced oil recovery? Perception.
Well, I think a big important thing to keep in mind is we always have new technology developments. One of the things that really bothers me is when people say polymer flooding is a mature technology, and they've been saying that for probably at least 15 years. And when you talk about a mature technology, it sounds like, well, there's nothing more that can be learned or done with it. And when I first heard that, I thought, this is a crazy statement. I mean, the guy who made it, I disagreed with fully half of what he was saying. So how could it be a mature technology, right? So, I mean, we are making, even now, substantial advances. And as a result of this workshop, we're going to make advances and things that we don't even think about 5 years from now are going to make a big difference. So that's kind of an exciting thing.
I would not say it's I would say the concept is mature. in the sense that when you know that when you increase the viscosity of the water, it will work better. But then you have to look at the details and the finer prints for sure. But when it comes to EOR, my only dream is that we change it. We have an honest look at what we're doing, and we say, look, what people have done in the world is working very, very well most of the time, even with sometimes limited understanding, because the thing that we will never understand anyway is a reservoir. It's a black box. We drill a couple of holes, we make models out of the holes, and we don't understand. But despite that, we managed to get something out to even decent volumes. But my hope is at least that in the future, if people decide not to do EOR, they don't come up with the irrational reasons that I encounter very, very often, which is one mention, like it's too expensive, it's too complicated, it's too risky, it doesn't work, and all these kind of things. So that if they come with reasons not to do, not to improve at least what they're doing, they can just come with a no, like, giving no and no answer is sometimes, well, no, we don't want. And it's much better than to say no, but it's too expensive, or we don't have enough data, or we don't have the people. So, I mean, when you really want to solve a problem, very often if there is no problem, sometimes there is no solution. So in that case, we have the answers. We know what they are. So, I mean, for me, it would be really a big step if people were moving away from irrational approaches, because we can find answers to these concerns. And then if what's left is a few technical things, that's where we are here to figure out. What Randy was saying is we'll try in the workshop to help people understand what is missing to make a case. But very often the answer is becoming more about economics and not technique, because the technique often is linked to economics. If you want, for instance, to make it work faster, one way is to drill new wells. So it's economics. It's not that the concept will not work. It's just you want to make it work faster. And when it comes to timing, then we come back to the money. So regulation, money, and as Randy was saying, if someone has a vision, well, normally it will work out just fine. So I hope it will be the case in more and more in the next over the next decade. Yeah.
And also, I would like to share what I've seen in this plenary session in the Ryder Scott. There was a guy from the hedge fund. He was showing that the only time that the oil consumption or demand that was low, maybe that's just a pandemic, it was like a exception 1 year. Apart from this year, we see that oil demand being increased every year. And there was like exploration and the new fields graph, which is contrary, decreasing every year. The money spent on exploration being decreased, but the new field being discovered even less. I mean, it's going like to zero almost every year.
Yeah.
And the huge demand in oil.
That's-
This thick,
the average discovery was 125 million barrels, which is 1 day of half a day, 1 day and a half of daily consumption.
Yeah, exactly.
This is that's why for me there is nothing rational left. It's just the old ways of doing things.
Do you are today and don't wait anymore.
I remember that one of famous company in 2020 said in strategic vision, that's the peak. 2019 was the oil demand. And like this year, the same company said that oil demand is going to increase in the coming 5 to 10 years. So I think oil demand is here, and we cannot just ignore this, and it's getting bigger and bigger. And I know that it's like 104 or 5 million barrels per day now. And yesterday or 2 days ago in Kazanergy Forum, OPEC. Okay, I understand. OPEC, the representative OPEC said that it's going to be 125 million. I agree. OPEC is more like a pro oil demand, but still there is like if we keep the same oil production, we need to have something to find.
Yeah, we have big
oil.
problems here with finding new oil.
Yes.
Yeah, I would like at one point for our listeners here. So many speeches on green energy and replacing oil, and between common people, This thing that the oil is a very bad thing, which harms our environment, which should not be producing, and we should to move forward sustainable energy solutions like nuclear and so on. So they should understand that without oil we cannot survive. So after once oil comes in 1850s, in U.S. in Pennsylvania, the earth and world and lifestyle changed dramatically. So the population increased from less than 1 billion, now it's 8 billion, and the life become very global, and all these devices, the computers, our dress, our food, medicine, all related to this oil. And if oil not come, the human life average age will be 30 to 40 years, maybe, with oil, with medicine, with all these COVID, how it calls, vaccines and so on. Human life improved much, and it's close to 100 years now, right? So we should understand that without oil we couldn't survive even, and we should rely on it. Of course, we should do it in more smart way, and more sustainable way, more ecological, because we now doing in a big trouble, because we are producing in average 3 barrels of water instead and 1 barrel of oil. So it's not my words, it's very popular, like a song. We are not oil producers, we are water producers, right? And we are water engineers, not petroleum engineers, because we're pumping out so much water. It's only global numbers 1, 2, 3, but in Kızılorda region it's 9.9 water and 0.1 oil, nothing, and still they are doing it. And every day, every year, the board of directors is picking clothes, or still going, still listen to social pressure. And in Kızılorda region, it's very they really in big trouble, because if they close the industry, they close the oil, thousands of people will be quit. What they will do? Be a criminal? What they will do? Or go to the streets and start to say, "Give me the money, feed me," and it will be a really big problem. And I don't think that they will all become businessmen or change the specialty industry majors. They will not do it. They will just require from the state, "Give me the job," and there is no much job in the oil industry. That's why it's a big trouble. And I think EOR must have and should done as soon as possible. And it's not related to only EOR, it's related to a rational using of resources, and people should find on the daily basis on this work how to improve the efficiency of their work, not related to EOR only. Road pumps, how to improve the efficiency of road pumps, these pumps, how to save the energy. And it's it's a big system which have an interaction between them, and it's very crucial. And I would add one more point about projections, how people are not correct in their projections. In 1980s, they said the chemistry price and polymer price will increase in correlation with the oil prices, and they said that polymer price will be too high and it would not be viable. That's why chemical EOR is a stupid way to improve recovery. We should stop. But in reality, what I've done after the Dachin was the first, major point to make this EOR technology, polymer flood, in wide application and become major. The second one, in the polymer manufacturers, they find a way to do it cheaper, right? So if we can compare using the price index, or consumer price, if you consider consumer price index multiplied by the price in 1980s and today, it have 10 times cheaper now polymers. 10 times, can you imagine? 10 times. They improved the technology, chemistry technology, and then they're now doing 10 times cheaper and still doing it viable and feasible and profitable. Of course, the scale become much larger, 10, 100 times, 1,000 times, maybe 10,000 times more than in 1980s. So this is about projections.
Which is exactly why polymer flooding, one of the advances why polymer flooding is more viable. I mean, obviously the cost of the polymer is a significant component. If that is decreased in cost substantially, which as Merritt said it has, that makes a big difference on the viability of the process today versus 10, 20, 40 years ago.
And it's going to be cheaper maybe in the future as well.
We hope.
Well, that's why we need EOR, because there is no oil to make the polymer because it's coming from oil. We are going in the wrong loop.
It's also come to the oil. From the oil.
So
It's a big circle.
Produce more oil, more polymer,
Yeah.
more oil.
More oil, more polymer flood.
Yeah. Thank you very much for today to have you joining this podcast. And I think we've discussed a lot about enhanced oil recovery, what it is and what kind of methods we have. It's economy of scale and the current trends, what we have globally and in Kazakhstan as well. And there is a seminar tomorrow and the day after tomorrow for 2 days. And you've just showed wonderful speakers, wonderful their topics. So I think there will be a great event and opportunity to discuss more. I think we'll have here a lot more than this podcast in seminar, the current technology and the solutions. Thank you for very much. If you would like to say more about today podcast, you're welcome.
I just say thank you very much for the opportunity. This is my first time in Kazakhstan, and it's been a real pleasure, mostly because of these guys have done such a great job of organizing everything.
Thank you for coming.
И спасибо большое. Это не мой первый раз в Казахстане, но I hope that there will be many more for a lot of good reasons, and we can have these discussions and longer ones, or not to go into details and let people learn more. Thank you.
Не первый и не последний раз, как говорится. Спасибо.
Thank you. Yeah. So I'm very thankful for Randy, for Antoine, and many speakers, as I mentioned, and our sponsors, SP Almaty section, KMG Engineering, you, Abzal, who supported us, and to make this event to be happen. We started 1.5 years ago, and it's like it comes like one moment, and today I couldn't believe that we all here, best experts of the world here to tackle, to find solutions for our challenges, and it's really inspiring. And I wish for us as a young generation, scientists and industry guys, it will be helpful. And I have hope. I believe that our outcomes and results will be implemented, and we will see the results after 2 years. And this seminar, we hope that we can do it in periodical basis and every 2 years. So maybe this year is Almaty, next time we will see Astana, and the next time we can go to regions, all the regions, and so on. So I have a hope that Kazakhstan can become a center for EOR for Central Asia and post-Soviet Union countries. So thank you again.
Inshallah. Thank you. I'm a member of SP actually since 2010. 2002. So you are longer, I'm sure. So thanks for SP as well for this hosting. This opportunity. Hope will be. It was a great for me podcast in very technical way. So I was really enjoyed this podcast. Thank you very much, and hope to have a very good seminar. Yeah.